Okay. Here, I just hit the record because I often forget, but I'm glad you sorted that out. And all of you, it used to be people would just use the WebAssign by itself, but now lots of people want to integrate this into their LMSs, and Cengage is getting better at this, but particularly first time through, it can be a process. So if you need help with that, just email me and I'll try to get you some help. All right. Well, let's see here. Here we are on week 2, and we'll catch. We missed a few introductions last time, and we'll catch up on those. But I figured first I'd share something fun. So there's a Blue Origin launch this morning. I only learned about this after it happened. I didn't know it was going on. Am I sharing here? My screen, you can see them who went up.
Yeah.
The one in the middle there is Carson Kitchen. She was a student in my astrophotography class, and then at my summer program at Green Bank. And she's now the youngest woman to have ever gone to space, which I thought was pretty cool. I don't know how well, I kind of suspect. So I did a little bit of digging, and it turns out her father, who's a professor at UNC, also went up on Blue Origin, I think last year. So it's private. It must be a family with a little bit of money, but still, it's kind of cool to live in the era where this is becoming more accessible to more people. And so, yeah, I spent a week with her at Green Bank. She was one of my best students in my astrophotography class. I think we'll see a blog from her and some of the resources I'm going to share. But yeah, pretty cool to wake up and learn that your student's now the youngest female ever to fly to space. These are the suborbital launches. So you make it up to the Kármán line, come down, the whole thing's, I don't know, 30 minutes, but still pretty cool. All right, so that was just a unrelated share. Okay, let's see. Basically, today is going to be a bunch of resources. So continue with orientation. We're not going to get into the details of Lab 1, but we're going to go more detailed than last time. Last time we did introductions, and interspersed in the introductions, whatever topic came up, I used the opportunity to give you some background information that was on a checklist of mine, and I think we got through most of that. So today we're going to focus mostly on the resources. I want to go back to the sign up page first, and in case I missed anyone. So let me get the chat open as well. Okay. I'm going to try to remember to put these links in the chat as I hit them today. I did send out an email this morning that had our recording from last time, and it had a bunch of these links. But there might be one or two that I missed. So here's this link again. If you haven't signed up yet, go ahead and get your name in here with your email list, just so the idea is I have this long list of like 100 people who have expressed interest in OPIS over the years, but that larger list doesn't need to be spammed every week as I share videos and links and resources. So you can put that in here.
Dan, since I'm teaching at 2 different places, do you want the 2 different addresses?
Nah,
Okay.
And you're signed up, you're good.
Okay.
So a number of you indicated last time you did not have a Skynet account. So I took care of that this morning. Sorry, I didn't do it earlier. I should have done this last Friday after we met, but I didn't get around to processing all this stuff till this morning. But the 3 of you should have received an email from Skynet. It may have ended up in your spam folder if you haven't found it yet. And if you don't have it for whatever reason, just email me and we'll sort it out. But this email is identical to the email your students get when we enroll them in Skynet and for completion of setting up their account. And I think your students will each get 1,800 credits corresponding to about 30 minutes of observing time. I think I gave you 1 or 2 hours worth of observing time. And if you need more, just ask and I'm happy to just give it to you. Okay, or if any of you who already have Skynet accounts, if you're running low on time, just ask and I'll make sure that you're loaded up personally. In this column, I asked whether you're teaching OPIS this semester or not. And so if you're, the reason I asked, if you are, I've already set up a WebAssign section for you, and I've gotten you attached to that section. And so you have access to the labs. If you're not, the idea is I'm going to add you as an instructor to one of my sections, and not with grading capability or the ability to change things, but you'll be able to view the labs and use them. And so for that, you're going to need a WebAssign instructor account. So that I've added this here. That's over here. Let me mute Christopher there. Okay. And so if you indicated no, and you already have a Cengage WebAssign account, come here and just give me your best guess as to your username and your institution code. It's normally taken straight from your email, so you can just dump your email back in there. If you don't have one, you'll want to go to this page right here. I've already loaded it. Are you a student? No. And you start with your email and continue on, answer the questions, and they create an instructor account for you. It's not fast. It usually takes them a couple days to process. Sometimes it gets lost in the shuffle. Basically, they just don't hand them out because students could just press that button and then gain instructor level access and view the answers to any of their products. So they do some digging around on the internet to try to confirm that you're an instructor. And if it's taking more than 2 or 3 days, or if you have like really immediate need, just let me know and I'll email my contact saying, could you move this one along? And once we have it, and I have it here, I'll load it into WebAssign. It still requires a little bit of guesswork. And the way WebAssign is set up is I can easily add any instructor from my home institution, UNC. I can see them all and I just click on their name. If it's at another institution, I have to kind of guess as to the username and as to the institution code. And normally it's an easy guess, but sometimes there are small variations. Like if it's a high school, they normally add dot and then the state. Sometimes community colleges, they add something extra. Sometimes the username is the full email address. Sometimes it's just what's before the ad. So I have to guess a little bit. And if I can't figure it out, I have to email WebAssign and Cengage again for assistance. But I'm usually pretty good at, I know most of the permutations. So if you answered no, get that set up, like do that today or now as we're going through background information. And because as we go through the labs, you're going to want to be able to view them in their environment. Viewing a PDF is just no good. This is an interactive product, so you're going to want to be able to interact with it the way it's supposed to be. Okay. All right. I think we have a few people who didn't do introductions last time. So we'll run through those fairly quickly and then continue on through the resources. So Brad, you popped in right at the end. I think it was a time zone issue. So do you want to introduce yourself?
Sure, I can do that. So I'm Brad Peterson. I am from Hastings College in Hastings, Nebraska. I went to the Astro eDunk meeting over the summer and was definitely interested in the OPIS stuff. So I came to learn more about that. I also actually remember reading about it in the physics teacher a couple years ago, and I signed up for a training session, and I think I actually emailed Dan to cancel at the last minute because I got COVID. It was a virtual training session, but I was actually not feeling great. And then let's see, what was the other thing? Oh, I guess the other thing I put this on the spreadsheet. While I'm not currently scheduled to teach it this semester, we do have a block schedule such that the class starts in mid-October and runs through December. So if things went super smoothly, maybe I could do a few of them. I'm not sure how that would work as a practical matter, but it's might be on the table for me to add it still.
Okay. And yeah, I'll just say that there is no obligation to do all the labs. Some places do all the labs religiously, going through them in order. some pick and choose and mix with some favorite labs of their own, etc. No implementation is the same as any other. As part of the NSF grant, my postdoc, Rachel Freed, there's a good chance that she'll come and visit you. We're nearing the end of the grant, so there may not be time to get everyone, but once you've implemented OPIS, she'll come out and do a site visit, not to evaluate you, but to better understand your implementation, since everyone is different. All right, let's see who else wasn't here Mohammed, you weren't here last time.
Yes, that's true. Hi, my name is Mohammed Al-Ikhtiar. I am a graduate student at University of Nebraska-Lincoln, and I'm teaching the astronomy lab this semester with Professor Evan Rich. So, yeah, that's basically it.
Okay, great. Yeah, he mentioned that he was going to come to the first one, but he had a conflict, and you're going to be coming to the rest.
Yeah, that's true. And I was supposed to join last week as well, but I had some sort of personal emergency. But
Okay.
I saw the recording, so everything should be fine.
Okay, great.
And I think I missed the email you mentioned because I don't see how do I get to this spreadsheet and write my stuff.
Oh, the spreadsheet it's in the chat.
Oh, okay, sorry, my bad.
Yep, I stuck it in the chat. If I forget to put links in the chat today, just remind me as we go. All right, and Anne, I don't think you were here last time.
Right. We had like faculty meeting last Thursday at this time. So I'm the chair of the physics department at Rhodes College. We're in Memphis, Tennessee. We're a small liberal arts college, and I learned about OPIS at the AAPT workshop in January, and I'm going to be implementing it this semester starting on Tuesday next week.
Oh, wonderful. Yeah, we did back to back. We did the AAS one day, and I think that went great. It was a full day workshop. And then the very next day was AAPT, and we're all exhausted. And I think we did a mediocre workshop, but you're here despite that. So that's great. Okay. I think that's it for this page. Let's see what's next. Okay. This is the YouTube playlist where we're dumping these videos. Stick that in the chat here. And let's see, since I'm in the chat, I see there's a question from Benjamin. I have a question about your lab 1. When is it appropriate? It's always appropriate. When you ask it. When particular.
I meant to say when it is appropriate, not is it.
Yeah.
Well, dyslexia of the fingers. So I went into the Cengage thing, and there were a couple questions I had. One is you have these links to let me bring it up so I call it the right thing, the glass site.
Yes.
But they don't actually take you to a video. It just takes you to a home page. And I don't know how to navigate from that home page to the things that you're saying are there.
The glass site. So you mean within the labs? We'll jump ahead.
Sorry, I'm calling it the wrong thing. Go scroll all the way to the top where you have the introduction to Skynet. Go a little further. Procedure week 1, click on that.
Okay.
Glass education videos.
Right. So you click one of these buttons.
But if you click on the glass education, that just takes you to their homepage.
Yeah.
Right.
That's what was confusing.
Yeah.
I clicked on that. I didn't know to click on those 2 buttons.
This page is poorly written. So
Yeah.
what I did and I'll probably mention this as we go along, updating the WebAssign product is a slow process. I have to submit the changes, and like months later it happens. I want to be able to swap out videos very quickly. So when I submit my stuff to WebAssign, it goes to a redirect site. This is the redirect site, and I can redirect it to the videos. And so we have the original video, and we have the glass enhanced ones, which we now have for most of the original videos. And
Gotcha.
those glass enhanced videos, they zoom into the region that I'm talking about. They have closed captioning. They put in little graphics like arrows and things pointing to what I'm talking about to increase, for visually impaired students, but also non-disabled students find them quite useful too. But yeah, this is just giving them credit. But it's it's confusingly written. I'll probably update the text here, but really.
Oh, I see a link and my eye
Yeah.
goes to the, and hand went to the link, not the buttons. Okay, thank you for that. The
Not
other
a
question
problem.
I
Yeah,
had
go
is,
ahead.
I'm actually going to start doing that lab today. And I was wondering, I haven't, everything's a rush right now. Have you
Sure.
already figured out the observation schedule to, are you still doing the phases of Venus? It doesn't look like that's part of your current curriculum.
No, I think it's there under lab 3. Yeah.
Ah,
It's at the bottom of lab 3. When I do my lab 3 is scheduled for an update, and I'll probably move it to the top of lab 3 with the Kepler third stuff following after it. But right
gotcha.
now it's still at the bottom of lab 3.
Got it. So have you figured out the observation schedule for Venus that is in the sky at the right time yet, or no?
So the way that normally works is when they're doing lab 1, lab 1 is, as we'll see, is kind of an introductory lab. They're learning the skills of how to submit to Skynet, how to process things in Afterglow. And we make heavy use of the solar system because the objects are bright and hence short exposure and hence cheap. If we're going to have a national curriculum, we have to not be able to expand without overwhelming the telescopes. So we make use of solar system stuff a lot. And if Venus is observable this time of year, they'll get one Venus observation then, and then they can pull up archival ones for all the different phases.
So we're relying on the archival one to get a full set. We're not
Yeah.
relying on them to do a full set.
Yeah, that's right. And
Okay.
it's tricky because often Venus is too close to the sun.
Right. And
to
and I was
get
wondering if you
all
had
the
figured it
things.
out for this particular semester or not, what you were doing. Okay, that was
Yeah.
my question. Thank you.
Sure, not a problem. And everyone just feel free to interrupt with questions at any point. The order that I have the information, it doesn't matter. Okay, so let's see. We were here. That's the playlist. And so the videos will be dumped here. And here's last year's playlist. I'll put that in the chat because we may not go through the material fast enough. If you're teaching this semester and you've never taught it before, then you may have absolute need of like OPIS Lab 1, Week 1. Today, we're mostly going to be talking about the various resources and won't get into the details of Lab 1 until next week. And if you need that right now, you can use the video from last year to get trained up. Okay. At UNC Chapel Hill, we have kind of a slow start. The first week, I don't hold labs because lots of people are still signing up, and we kind of pitch the labs in the introductory lectures. Then we have an orientation week, which is kind of, it's short and just gets them ready. Then we have Labor Day and we have a wellness day after, so I don't hold labs that week. And so my labs don't actually, Lab 1, Week 1 begin until September 9th. So I'm still ahead of my schedule, but I may be falling behind your schedule. So you have this resource. Okay. Next, I wanted to, where is it? Kind of describe a little bit about our facility, tool, and curricular ecosystem. So here's a convenient plot showing what we have and what we're where we're hoping to go. On the bottom, we have our facilities. So Skynet. Though the word Skynet can refer to many things, it can refer to the hardware, our global network of telescopes. There are maybe about 20 optical telescopes. They're usually only about half or so are regularly online. And so of that half, some will be weathered out or et cetera, or may have a temporary maintenance issue. On any given night, there's probably 3, 4, 5 to choose from. So Skynet can refer to the global network of telescopes. It can also refer to our telescope control system. So this is back-end software architecture that, there's a database where observations are kept, and then it draws from that and sends observing requests to various systems. Depending upon the user may say, I don't want this system, or I do want this system, or I don't care, and I want the moon this close or this far away and the sun this far down, all the various constraints, and you couple that with Earth geometry and timing, and it's a pretty sophisticated scheduling system. I think it's probably the most advanced thing out there, and it's only going to get better with the release of Skynet 2. For the past couple years, we've been rebuilding the entire Skynet system to be what we have right now is over a decade old. It's good for scheduling optical telescopes that are doing imaging, but in the future, people want to do polarimetry and spectroscopy and multiple instruments on the same scope and auto guiding and radio telescopes and all the different radio observing modes. So we've been spending a lot of time redesigning what is an observation. Can you define it very generally that works for optical, radio, perhaps even space-based systems? We're starting to consider small sats, CubeSats, that kind of thing. And we've made a lot of progress on that. The back-end design is mostly done, and we're now beginning to work on the new web interface. So Skynet 2 will hopefully roll out in about a year, and it's going to move us more than a decade and a half into the present. I think it's going to be the best thing out there for maybe a decade into the future. Anyway, Skynet also refers to the interfaces from which you can submit observations. So it's not just a command and control system, but a scheduling system, a web interface, and you and your students will learn how to use that. I guess I'll kind of peek at these resources as I mention them. So here's the Skynet 1 website. The Skynet 2 website is just spectacular. Some of the features that my programmers are building in, it's like having a good chunk of Stellarium built into the interface that we've built up from scratch. It's pretty sophisticated. And again, this is over a decade old technology. I'm looking forward to retiring it, but it's still right up there with what can be done these days. And we'll learn how to use this next week. Next week is Lab 1, Week 1. It's about learning how to schedule observations in Skynet. And so like I went to the optical observing page, and you can see my recent observations here. I can add new observations here, ones that I've done previously. Click on one of these here. This was taken with the Triple RT telescope in Southern Virginia, a nice Messier object and different filters. And, this is not what we use to do the detailed image analysis, but it's just to collect and preview your observations. Okay, that's Skynet. Then, trying to grab onto it here and slide it back over. What is going on? Here we go. Then there's Afterglow, and we've been building this for the better part of a decade. There's probably about $1 million of NSF and DoD funding that's gone into this. This is the image analysis interface, and over the past couple of years, it's become much more capable because we've added all these features that the DoD grant needed. It's directly tied into the Skynet database, so students don't need to download and re-upload their data. It's web-based, so you don't have to install anything, which is often a problem, particularly in high school systems, which are locked down at middle school. And as we make improvements, it happens transparently. You don't have to update anything because it's a web page. The next time you load the page, the updates are there, and we'll learn how to use this system, all sorts of things you can do, adjusting brightness and contrast. So that was Saturn. Here are some of Saturn's moons. You can measure brightnesses, so it does photometry. You can do photometry of thousands of objects, and it's not going to tax your machine. That's done server side, and the information sent over. You can measure distances between things. Like from Saturn to, that's probably Titan, and angular lengths, and just all sorts of capabilities here for image analysis, student level. But the algorithms behind the scenes are professional level, so you can actually publish off this as well. I didn't mention, so Skynet hardware, right now we're mostly an optical system, but we do have one radio telescope. Here it is in Green Bank, West Virginia. This is 6 stories tall, 150 tons, 20-meter dish, and your students will be pushing it around and observing the invisible universe. We start to incorporate this at the end of the OPIS curriculum, get just a little bit of it. And then in the follow-up curriculum, it's 50% radio. And funded by the DoD, This is being expanded greatly. They're funding the rewrite of Skynet to Skynet 2. This one telescope is really wedged in an optical observing system. It's very janky how we inserted it, but the new system will be designed to take on all sorts of new radio telescopes. Here's a 30 meter, a 26 meter, and a 14 meter in Australia. They'll be integrated, and they're building brand new, very modern signal processing back ends that will start to distribute back to the Green Bank telescope. We're integrating 1 to 3 telescopes in Western North Carolina. Puerto Rico has a 12 meter that we're integrating, and possibly more to come. So hopefully within a year, this will be a very unique resource. And again, we just skim it with the OPIS curriculum, but you just touch on it, but it becomes much more fundamental once we get one level up. Then we have the Astromancer site. This is now our collection of little tools. Most of them were designed for OPIS, though some of them are for that next level MW curriculum. And we've recently been building them in this new framework here. Different labs may call on different tools. Like here's a tool from Lab 3, where they're measuring the angular separation of a moon from a gas giant, like I just measured with Saturn. And that was probably Titan. And as they collect this data, then they can do this. This site is not just for graphing, but modeling. There I'm modeling the semi-major axis, change the phase, the period is probably something like that, and then a little bit of tilt, and we'll learn how to do this stuff more carefully, but I just measured the orbit of, in this case, the data was Triton going around Neptune, and with that, I can work back and calculate the mass, and that's one of the key goals for Lab 3, the mass of the central body, the mass of Neptune. And there are a whole bunch of these tools that we've built for this curriculum we'll make use of. What else? Okay, so that's kind of the base level, the tools. On top of that, we have our curricular ecosystem, beginning with OPIS. That's the training that we're doing this semester, Our Place in Space. This is an introductory curriculum, like 100 level curriculum designed to pair with standard Survey of the Universe courses. It's now in use by probably close to 36 institutions, serving 1.5% of all introductory astronomy students in the nation today. And there's probably another 0.5% out there who are using their own versions. You know, they bought Telescope Time. They're not using this particular OPIS product, but they've taken the OPIS product and modified it for themselves. So it's not nothing, 1.5%. It's a toehold, and NSF is particularly excited about growing this. So we'll learn all about that. But I also want you to be aware of some of these other efforts. I've mentioned this before, but we got $2 million from NSF to do OPIS and $3 million from DoD just 3 years ago to make this follow-up curriculum. So it's like a 200 level curriculum. If OPIS is 100 level, this is 200 level. OPIS, the students are doing single shot black and white. There's a little bit on color combination, but mostly everything is designed around a single exposure, black and white image, doing science and off of these images. And we do that because we're trying to expand to a very large national audience, and we don't want to overwhelm the system. With MW, the idea, these are students who've come back, and so there are probably fewer of them. It's a second semester course. Maybe these are introductory into an astronomy major. Being fewer of them, we can give more credits per student. They work in teams and pool their credits, and they have more credits per student. So instead of having like 30 minutes of time to work with, the team has maybe 8 hours of time to work with. And so we can image things over and over and over and stack for depth. We can do different filters and combine for color. And the title is actually Astrophotography, the Multi-Wavelength Universe, but astrophotography is more of a hook. This really is a science curriculum, and it's equal parts optical, radio, and also with a bunch of archival infrared, primarily Spitzer, mixed in. And I can show you just a few examples, like teaser stuff. This is our, I didn't use this, I've taught it twice now, and we're still rapidly developing the materials. I'd say that the tools are 90% done, the text is 80% done, and the videos are 70% done. So it's still a product being developed, and it's being developed by people who've taught OPIS once. Once you teach OPIS once, you're invited to join the MWU community of educators, and they've been helping to develop it. I've been doing most of the writing, but they've been doing most of the testing and planning. And it's a very different curriculum. OPIS being meant for a larger audience, it's, I'd say, hate to use the word cookbooky, but it's a little bit more cookbooky. You know, they go through the WebAssign lab, it gives instructions, they do it, and then they answer the questions and submit their images, all in a flow there. The MWU course, it's a little bit more investigation driven. We do have module guides, but all their targets are different. They work in teams, they each pick different targets. There's deeper solar system explorations, stars, formation, evolution, death, galaxies, and galaxy evolution. It's the OPIS curriculum is really about kind of the key lessons that you teach in the 100 level course, our place in the grand scheme of things. And we use the cosmic distance ladder as an organizing scheme for that. We start nearby, work our way farther out, and cosmic distance ladder is the technical backbone upon which we learn our place in the universe. And I'll describe the OPIS labs in more detail in just a second. MW is more the orthogonal stuff, like how do star forming regions work? How do galaxies work? The kind of the squishier stuff. And so they learn how to make images, and then their work products are a blog. Each group produces a blog. So it's focused on communication and writing and explaining what they've done. And here are just some examples of different targets. This has a lot of Spitzer in it. I can just tell from the color. This has more, for whatever reason, I stopped posting at some point in the semester, so there's no galaxy stuff here. A lot of star formation, star clusters, and you can see it's not just about making pretty pictures. They do HR diagrams. They model the HR diagram, measuring ages. They do radio, so pulsars with period folding, and they even establish polarization in the pulses. Solar system stuff. I mentioned Carson Kitchen, who's youngest woman in space now, and here's her blog from 2 years ago. And some stellar evolution in radio. This is radio imaging. This is Virgo A, and etc. And then down here we'll have more solar system targets. And lots of lunar imaging that they did. This is actually a mosaic, 5x5x3 colors, and all pieced together. After they'll have software, they can piece these things together and make images like this. Anyway, I just want to mention the MW curriculum because it's exciting. It's really exciting. And so once you become OPIS experts, if this is something you're interested in, having another course for more advanced students, know that there's something there. Here's a page. It's a little out of date where I was learning how to do astrophotography. To do this course, I had to learn how to do it. We built all these tools. Most astrophotography software is very complicated, and we had to build student level versions that students could ramp up quickly. And so like here's Orion with some Spitzer stuff mixed in. These are ones I did just in getting ready. Fornax A. And we really focus on the multi-wavelength. Here's a good example, the Crab Nebula. In Nebula, there's just a basic LRGB combination. Dim it down, add in the H alpha, the O3. Here's some Spitzer data showing synchrotron emission in the middle. Some Chandra data with the X-rays. And so, just think of all the cool science, squishy science you can do with this kind of stuff. We do Strömgren sphere calculations in the star forming regions, etc. Okay. That's multi-wavelength universe. In future funding, we're going to go in two directions. We're going to peel off some of these exercises and simplify them for a K through 12 audience that I know Art and others are interested in. And we will be also going one more level up the pyramid to a 300 level, developing curricular units for Argus. And if you don't know what Argus is, I'm its biggest fan. So this is the brainchild of Nick Law, my colleague at UNC. And we just got $24 million of funding to build this thing. Think Rubin, the Rubin telescope, the 8 meter in Chile, the biggest ground-based effort. $1 billion has gone into Rubin. It's going to image the whole sky every 3 to 5 days by tiling, spot by spot by spot by spot. And it takes 3 to 5 days to tile the whole southern sky. Argus is the opposite approach. It's just brilliant. It's 900 8-inch telescopes. And due to the cost of the cameras have gone down, so they're actually thinking of upgrading to maybe 11-inch telescopes. But if you use 8-inch telescopes, it's like a 5 meter, could be even bigger. And they all look through this hole in the ceiling. This will probably be at McDonald Observatory, though it's not certain yet. It's going to take 3 to 4 years to build once they've chosen the site. But it looks through that opening, all shooting different parts. And so basically they're imaging the whole sky in a single shot, unlike Rubin that does the whole thing in sequence. So it's a 55 gigapixel camera with 1.4 arcsecond resolution built out of 900 telescopes. It will image once a second during dark time. And that's a data flow rate that matches Netflix worldwide streaming, which is just wild. And so this is never been done. I'm really excited about it scientifically because after that 1 second exposure, he can process all the data, image difference, and find anything that's changed in a 1 second time scale. And I'm going to be building telescopes around it that can slew within 1 second with advanced instrumentation. No one's ever probed the 3-second sky before, but this is the plan. And it can integrate. The new cameras are noiseless, so you can just keep adding the images. So you get every time scale, 1 second through the 3 to 5 day Rubin time scale. So Rubin will find things that change on a time scale of 3 to 5 days. This will find things that change on every time scale. And once you stack for 3 to 5 days, it's almost as deep as Rubin. And instead of 1 billion, it's 24 million, 1/40th the cost. So super exciting. And anyway, we're going to be building curricular units around this as part of our next round of funding, hopefully. Anyway, I just wanted to show you the big picture. And we're going to start here on this rung, and hopefully you stick with us over the semesters and do some of the more advanced stuff as well. Okay. Any questions about anything? I guess I could check the chat, see if I've missed anything. I don't think so. I don't think I need to insert any of those links, but okay. Any questions about any of that? Okay. So let's go through the OPIS sequence. I'm just going to say a few things about each lab. Just give you an idea of the flow of the sequence. And then we'll look at individual resources. And that'll probably get us to the end today. So it's a 9-lab sequence. And this page right here, it's an older page. We also offer the labs to the public. And this is the public page. I'm just here because I have a nice little picture for each one. So it's a visual aid as I'm talking. But we probably get 50, maybe 50, just astronomy enthusiasts of all ages do the.
Could you put that link in the chat?
Yep.
Thank you.
Now your students won't sign up this way. In fact, if I catch them signing up this way, because it all comes through me, and if the email looks suspicious, like in one of your university emails, I say, now, it's a violation of your university's honor code or ethics code to take this while you're taking that, because you don't want them doing this and getting the answers and then using it to cheat. We haven't had any instances of that to my knowledge. But it's the exact same labs, and just members of the public can do it. It's self-paced. They use the videos. They're not getting the help of an instructor or TA. They'll all answer questions as long as it's not too much. And they just do it at their own pace, and they seem very happy, and they get a certificate at the end. Anyway, your students will sign up through the WebAssign process. And this is also WebAssign, but I create your WebAssign section and Skynet section, and it's not handled through this page for your students. Anyway, lab 1 is not super heavy on the science. It's more about building the skills. Takes part in 2 weeks. In the first week, they're learning how to use Skynet to schedule observations. Again, a lot of solar system observations, but also some deep sky objects and things of interest as well. And some dwarf, kind of the fainter things on the solar system list would be like dwarf planets, Pluto. So they find these things in the star field. And in the second week, they learn how to then upload them into Afterglow and do some of the measurement things that I quickly demonstrated there. And they'll measure angular sizes and compute percent errors and some basic things, but basically it's about building the toolkit. And they love it because they're taking pictures of all sorts of cool things. You do have to set some expectations. Often they think the solar system pictures will be the same quality they've seen, online, where those pictures were taken by spacecraft in orbit around the planet. And so you got to set the expectations a little bit. Then we put in our observations for lab 3 before doing lab 2. Like lab 1, lab 2, depending on what version you do, it's either a 1 or 2 week lab. And you put the observations in for lab 3, because lab 3, we're going to do Kepler's third. We were talking about a little bit at the beginning here. They monitor a moon going around one of the currently available gas giants for 2 weeks. They don't need 2 weeks of data. They need 5 or 6 successful observations. So we like to put it in a little bit early. And so, normally the flow of this is you do your pre-lab talk, and then you say, okay, but before you get to work, everyone open your laptops. We're going to put in our observations for this future lab, and you walk them through that. It's good not to leave that up to them, to do it as a group, to make sure everyone puts their observations in a timely manner. Otherwise, they'll forget, they'll try to do it the night before, and they won't have enough time to get the stuff back. So they put the observations in, and then lab 2, this is one of our non-Skynet labs. When we designed this curriculum, we sat down, as I think we talked about last time, and said, okay, it's not about the toys we have. Our old labs were built around the toys we had. We had a 3.5-inch telescope or telescopes. We had a planetarium. What can we do with these things? And the things you can do with them don't often connect to what you teach in a Survey of the Universe course. So we said, what do you teach in a Survey of the Universe course? And then what is the most appropriate resource, the best resource that we have to convey that lesson? And often the answer was Skynet, but not always. And this is one of the examples where we opted for a more traditional lab. We actually have 2 versions of this. The version I like has physical models. We have a globe, we have a 12-inch ring light. This is just basics, how the seasons work. They take a lot of measurements for different season configurations and a whole bunch of different latitudes. They measure length of day. They measure the sun's elevation angle above the horizon, and really develop a great intuitive understanding by making a lot of measurements and making graphs. And students actually end up, at first they're like, I'm going to have to actually measure things on a physical apparatus instead of just use my laptop, but they tend to like it. So the lab kits do require a little bit of time to prepare. So they're about $80 a piece to get the lights and the globes and the protractors. And sometimes you have to build PVC cages, put felt over it to block the light from apparatus to apparatus. And so most institutions don't use the globe version. We have a fully Stellarium-based version as well. And they differ. In the globe version, you have a God's eye perspective. You can see geometrically what's going on. In the Stellarium version, it's ground-based view of things. They both teach the same lessons, but from different perspectives. Then we move into lab 3, their data's come back. Again, at the beginning, you put your observation in for lab 4. Here, you're doing 2 things. Do we live in a geocentric or heliocentric universe? And you're using Venus size and phase data, angular size and phase data to show that we live in a heliocentric universe. And that's pretty quick. And then the main activity that we add in here is a Kepler third. And we figured that's an important enough lesson. We have to build it in somewhere, even though it's not strictly cosmic distance ladder. And as I said, they've already collected observations of a moon going around a planet. I even demoed the tool. And we'll go through it in more detail when we get to lab 3. But they measure the orbit, semi-major axis period, and using Newton's form of Kepler's third, they calculate the mass of the central body and a percent error. Then we get into the cosmic distance ladder. And of course, there are many, many rungs in the ladder. We had to boil it down to the key ones to fit it in to a semester. Parallax is obviously key. I like starting with a manual exercise. It's written in there. Some institutions do it and some don't. They go straight to the astronomy. You can find a similar setup up on the top of the building that my students meet in. There's this nice long wall, straight, and across the way we have like a smokestack on a building, and farther away we have a water tower. And so they measure the angle to, say, the smokestack from both sides of the deck, measure the length of the baseline, standard kind of parallax measurements. So they get a really good manual physical experience first. Then they go in and the class collectively observes a main belt asteroid using simultaneously Skynet telescopes in the north and the south. So the baseline is the Earth. And actually, as part of the Globe Lab, they measure the size of the Earth. So you can see how it builds using the size of the Earth. We can get the distance between the observatories. In their astronomical images, they measure the shift, the angular shift, calculate a distance. In this lab, we also, using archival data, do the distance to Venus and establish the astronomical unit. And then we do stellar parallax to Alpha Centauri. So Earth baseline parallax for solar system things. Then once we've determined what the AU is in kilometers, we measure the distance to nearby star. Of course, that's archival because those observations have to be 6 months apart. But the main belt asteroid is not archival. In every lab, every Skynet lab, they observe at least one thing. Some's archival, but something is observed. Lab 5, moving farther out, we go from parallax to standard candles. Here we do R Lyrae, Cepheids, and type 1As. The class observes an R Lyrae. It's a big observation, so it's one observation shared by the class. And they learn about period folding. They measure the period. They show, okay, it's short, so it has to be an R Lyrae. So its average luminosity is this. They measure its average brightness, calculate the distance. And then they do it for a Cepheid in a nearby galaxy. To see Cepheids in nearby galaxies with small telescopes, they have to be luminous, which means their long period. This one is 60 days, so it's archival. And then they do the peak brightness of a type 1A supernova. And that's, of course, archival, but it's one that was discovered with Skynet. Lab 6, you don't want to do Lab 6 without Lab 5. It's the application version of Lab 5. Now that they've learned how to measure distances to globs, nearby galaxies, faraway galaxies, we do the great debate of 1920, the Shapley-Curtis debate. We give them information on our Lyraes in a bunch of globs, and using one of the astromancer plotting tools, they calculate the distance to each and make a top-down projection of the Milky Way and determine Milky Way sides and our place in it, not at the center. And then they observe some what were then called spiral nebulae. And we now know that they're galaxies, but they didn't know back then. And we give them information on a Cepheid in each one. They calculate the distance, they measure the angular size in afterglow, just like you saw me do measure the distance between Saturn and Titan. And then they calculate the physical size and show that the Milky Way is not different in physical size from spiral nebulae typically. And so we're not unique. Again, the lesson of our place in space. But it's an application of these skills they learned. Lab 7 is unique, and I really like it. This is our spectroscopy lab. Normally what you do in an introductory astronomy course is you have a hydrogen lamp and you're looking at it through a grating and making some measurements. It's kind of boring because it's just a lamp sitting there. So here we're doing spectroscopy, but we're using the radio telescopes. So here they're learning all sorts of new things. They're learning how to do radio observations. Turns out spectroscopy is super simple in the radio. You always get a spectrum. Whether you want it or not, you get a spectrum. And we have them do 12 lines of sight along the plane of the galaxy, and they're measuring hydrogen. Hydrogen has an emission line in the radio, and they're measuring the redshifts, and they construct the galaxy's rotation curve, which is a standard topic in survey astronomy, the rotation curve, and they basically weigh the galaxy out to different distances, out to our distance. And we also give them the LMC and SMC so they can go farther out, and they realize the mass keeps increasing out beyond the visible light radius. So dark matter is a caret in this lab. It's a little bit trickier mathematically. There are some trig functions. Everything else is algebra, high school algebra 1, but they don't have to deeply understand the trig functions, and the execution, there's a lot of background, but the execution's pretty easy. Then the final 2 labs, one's new, so it's not here. It's about Hubble's law, the very top of the cosmic distance ladder. One is not Skynet based. This is about really understanding what's going on, that it's not, people think in the beginning you had all this space and it was vast and empty and all the matter was here and then it exploded. And that's not at all what happened. That's not what the Big Bang is. It's not an explosion in space, and it's an explosion of space, so to speak. And so we really drive that home here. We make little one-dimensional universes with 5 equally spaced dots, and they're expanding at constant decelerating and accelerating rates. And they have godlike powers. They can stop the expansion and measure distances between the dots and make Hubble law plots, velocity versus luminosity distance. And they see in the accelerating and decelerating ones, it's not a straight line. It curves at the higher redshifts. And they compare it to the type 1a supernova data and conclude that we live in an accelerating universe in dark energy. In the final lab, they measure Hubble's constant. And this is a capstone. It combines things from 5, 6, 7, and 8. I've identified 7 spirals with that hydrogen emission line in the radio close enough that they can take a long spectrum, see it, measure the redshift, which in this case is cosmological. We give them a Cepheid in there so they can calculate the distance, and they get Hubble's constant. And for any one galaxy, it's probably only good to a factor of 2. But across the whole class, you average these out, you get about 70 kilometers per second per megaparsec. And the 9th lab also does it with the CMB. Measuring little blobs in the CMB, you can also get Hubble's constant. Anyway, that is the flow of OPIS. Questions about that?
I
Benjamin.
have a quick question. Oh,
Yeah, go
sorry.
ahead.
Go ahead, Benjamin.
Okay. That was resting hand. Was it
Oh, okay.
resting grumpy face, resting hand position? Go ahead.
So my question is about how long each lab takes. I'm thinking each lab is 1 week, except for the first lab, which seems like it's 2 lab sessions.
That's right. At UNC, we have 1 hour, 50-minute labs, and they're all 1 week labs, except for lab 1. And lab 2, if you use the manual globe version, it takes 2 weeks. If you do the Stellarium version, it takes 1 week.
Okay. And do the students need to know Stellarium before that lab?
No, they learn it as they go. It's one of the resources we teach them. Yeah.
Great. Thank you.
And they use Stellarium not just in that lab, but in other places as well. Okay, let me plow through here. We got like 6 minutes, but I've already shown you those resources. There's, of course, Stellarium, free planetarium software, works on all sorts of different platforms. During orientation week, I make sure that their Skynet accounts are set up. They can get into Afterglow and the Astromancer tools. Make sure they all get Stellarium working on their machines. MacBook Pros can sometimes be a little finicky, but you can make them work. Make sure they're in WebAssign. So WebAssign. I somehow ate up more time than I thought I would. I don't know how I did it. So I'm probably, there's too much to show. So the labs are here in WebAssign. Let me cycle back to that in a second. Let me just show you the other resources, because since we're about to run out of time, we'll probably save the WebAssign resource and do it as we're doing lab 1 next week. And these are just different WebAssign things. So other resources, I'll mention them in the final few minutes here. We have all the videos, and so this is the Skynet University site. You scroll down here, the first rung are the videos, and the students love the videos. The education research shows that they're really about the videos. Students don't like to read anymore. And actually, I probably need to redo some of these videos and break them into shorter pieces because of TikTok and whatnot. They don't even like a 5-minute video anymore. It needs to get down to 2 minutes or something. We have orientation videos at the top of each lab. Let me just go into like one of these here. Here's OPIS Lab 1. And so when I show you the WebAssign product, you'll see there are these overview videos, introduction. Everyone has like a 2-minute introduction saying what we're going to do. And then in the first one, I talk about the instructions, but then there's an overview of the background, an overview of the procedure. And looking at the YouTube record, students tend to skip the overview videos. That's okay. They're there for them. They're also there for you as instructors. If you're trying to figure out what your pre-lab talk should look like, you can watch these and this will give you a good idea. It's also good for the students, after the lab, before the due date, they're trying to piece it together. What was said? I can't remember. They can watch this and get a similar version of the instructions. And then each lab has how-to videos embedded in the part of the lab where they're needed. And as I said, there are 2 versions of these. There are the originals and also the accessibility enhanced. And we're starting to build up a library for MWU as well. Other resources. On your orientation day, I try to get them excited. And so there are, let me actually put the video site here in the chat. Here, just a collection of images. Like here's a picture of Cerro Tololo and the prompt telescopes, the little ones here. Construction video, what happens every night when the sun sets and the domes open. Some videos of the telescopes and what it's like down there. And in Australia, here you have snow coming. We're often above the clouds, so that's a cool thing. Radio telescope, some images to set expectations of like what a in-orbit picture of Mars looks like versus a picture they can take. So these are resources that are here for you to use in your orientation to get them enthused. Stick that in the chat. Also, use this with a little bit of caution. If you're trying to get them excited, it's good. These are pictures that we've had 2 astrophotography groups purchase time on the telescopes. And it's not cheap. They pay like 20,000 bucks a year for the privilege. These are all APODs. They're not just pictures they took, but they won Astronomy Picture of the Day, which is really, really hard to do, over 24 times now. So these are the APODs that we've collected over the years. Here's the other group. They actually built a 32-inch telescope down on the site. And you can show them this to your students as well, but with some caution because they're not going to be making pictures like this. You don't want to set improper expectations. In OPIS, it's all single shot, black and white. But they will be a part of lesson 1 where they can explore color combination. And then the last thing I'll mention here is the grading guide. And we'll have a whole week on how to use the grading guide in a couple weeks after we get past lab 1. And we'll also probably bring Kate Meredith in to talk about accessibility that week. Put that in the chat. You don't have to follow the grading guide. I made it for my TAs and they find it super helpful. Most things in the labs are auto-graded, which is great, particularly if you have hundreds of students, which some of us do. And but some things you still have to grade manually, like short answers, images, graphs. And so here's the sections in which they appear, what it is, how many points are there by default, and recommendations on how to distribute the points. And bold things are when you're going to check, check for cheating or check something in Stellarium. Every image from Skynet, every graph from Astromancer they submit has their name embedded in the EXIF data. And so we show you how to get an EXIF viewer built into your browser. There's mine. And so you can click on any image and see who actually did the work. And so we have some good one-click cheating checks built in here. And there's a tab for each lab. So that's a super useful resource as well. But of course, you can grade however you want. I find with my TAs, even with this well-defined grading guide, their grading can vary by like a whole letter grade. One, it's some people may be, instead of getting a B, they would get a C with this TA and A with that TA. So even with the grading guide, you're gonna probably have to think about how you want to set your grades. I use curves, but a lot of people hate curves. But you'll get a feel for how many points correspond to what letter as you go through this. Anyway, we're at 4 o'clock. I didn't get into lab 1. I didn't really expect to. I hope to show you a few basic things in the WebAssign environment, but I can easily do that next time. And next time we will do lab 1, week 1. And I know it's 4, many of you have to go, but I'm happy to stick around and answer any questions as well.
I have a quick question. Sorry.
Yeah.
So about signing students up for Skynet, I know your
Yeah.
email said we could send you a list of names and emails, or once they all get signed on to the WebAssign class. If I send you the list of names and emails, is that going to generate an email that goes to each student?
Yes. So I'm glad you asked that. And I actually prefer that you send me a list of, I actually don't even need the names. I just need the emails.
Okay.
In fact, if you have them on the same line, I have to spend the time erasing the names. If it's in a spreadsheet, I just grab the emails. But the process here is you've all signed up on the web page. I created your WebAssign sections. That's done. Everyone has their WebAssign sections now. And then the next thing is to create the Skynet accounts. And you can either say scrape the names from WebAssign, they're all signed up or mostly signed up. And I can scrape the names, or just more easily, you can send me that list, your class list of emails, and I'll generate the emails. They each get an individualized email, automated email from Skynet with a individualized registration key. They just click on the links, enter their name, email, a few basic questions, standard for setting up accounts, and the account is ready to go with 1,800 credits already there.
And we can add like a teaching assistant or lab assistant to that list?
Yes, absolutely.
Okay, thank you.
And just to say one other thing is, I create a group in Skynet. I add you, any TA that you want as administrators of the group, and I put extra credits in there, usually 7,000 to 10,000 extra credits. This is for doing like the parallax activity, the RLARI, but also you may have some students that burn through all their credits. And you shouldn't chastise them for that, because the ones who burn through all their credits are the ones who are having fun. They're trying to make colored pictures, and they're the ones that you can turn into majors. And so I give you some extra time, you can just give it to them. And there's a little instructional video on how to sign up straggler students as well as part of that. Brad.
So at this point, if I wanted to add OPIS for this this term, I would probably have to buy the access through using department funds rather than having the students do it for reasons. Can that be arranged that we would like buy 24 whatevers and then we could distribute access codes? That's doable.
Yep, yeah.
Okay.
Most places they leave it up to the students, they assign it as a textbook. But since it's so late, you may not be able to do that. Some places, a small number of places, they buy the access cards for the students, and those can usually get shipped out in a week. Email me and I'll put you in touch with the well, if you don't have the information, there's certain information like a bookstore form to fill out. But if it's a rush job, email me and I'll make sure you're in contact with the right people and have the right instructions. And then, of course, the other mode is some people just purchase Skynet time. We can do a contract with UNC, and you don't have to use OPIS. You can, do whatever projects you want. There are a lot of people will take the OPIS curriculum, download it out of WebAssign, and create their own version. And I'm totally cool with that. Cengage probably isn't, because it's technically their IP, but I'm not going to tell on you. And modify a thing or two, and who knows. And either way, Skynet's getting money for the time, either path.
Yeah, seems like at least the first time or two, I would probably want to use the WebAssign, and then if I have brilliant ideas for modifications, I could start working on my own thing.
And I'm always doing updates. I have a whole bunch of updates I need to do for Opus. One advantage of staying in system is those updates happen automatically. If you pull it and make your own, then you'd have to go hunting for the updates. But maybe you've made something so different you don't care about my updates. All's good.
Excellent, thank you.
All right. Anything else? Yes, Benjamin.
Just on a slightly different topic. So I have an observatory dome, I think you know,
Yeah.
with nothing in it, but there may be an opportunity for me to get some funding to equip it. Who's the contact on your side that I could work with? Because I want to make sure we can integrate things, you know, obviously you want to do some pre-planning.
Yep. Vladimir Kuprianov. I don't know if you have his email. I can pull that up real quick and put it in the chat. He may be a little slow to respond.
Yep,
He's
I have it.
Oh, you have it? Okay. He's had to take 6 weeks off due to personal emergency in his family, but he's just now coming back, so he may have to do a little bit of catch up on Skynet 2 and everything else in his inbox.
That's fine. I'm not in a hurry, and I'm actually out for 2 weeks starting this Saturday myself.
Okay. Yeah.
Thank you.
Anyone else? Okay. Sorry for dilly-dallying and running over, but I'll try to stay on time better next time. Okay, I'll see y'all next week, and I'll post this one today.
Thank you, Dan.
Thank you.
And Dan, I'm not going to be here for 2 weeks, just to let you know. Same reason.
I surmised.
Okay. Nice to see you. Ciao.
All right, if there's nothing else, I'm going to hit the end button. See y'all.